Hi, welcome to N8.3, Ratios, Rates, and Proportional Reasoning. So, we've learned in previous years that ratios have two distinct kinds. You have part-to-part ratios where you're showing ingredients of this kind and ingredients of this kind and how they compare to each other. Or you can have part-to-whole relationships where you're showing ingredients of this kind compared to all of the other ingredients, kind of like the denominator of a fraction. In this outcome, you'll be able to convert pictures and comparisons and show it in mathematical language with symbols using a ratio. You can explain how ratios are related to all of these guys, and you're familiar with them: fractions, rates, percents, and decimals. All of those things we've learned, a fraction and a decimal especially, show part of a whole. And so that relates back to what we were just talking about up here, that ratios can show part of the entire whole. I know that ratios, rates, percents, and fractions can be compared using multiplication and division. You're never going to use adding and subtracting to compare ratios, rates, percents, fractions, decimals. If you're going to do something to one side of your fraction, you're going to do something to the other side. It's always multiplying and dividing. You never use adding and subtracting to do this kind of stuff. And why do we use these things? Well, here's some good real-life examples. Cost of a music download. If you're going to download 40 songs, you have to multiply that cost per download. Rate of speed of a car, and I have an example coming up on how to do that ratio question. Maybe population samples of animals. If you take a small population in one area, you would multiply that by the rest of the province to find out what the population of moose are for the whole province, maybe. Chemical mixtures for hair dye. If you use the wrong ratio, you will end up frying your hair. Be bad. Preparing large meals for multiple people, so you might have to triple or quadruple a recipe, and what does that mean? Or maybe you're doing servings of meat per person, how much each person is going to get. Another common example for our farm kids, oil and gas mixtures for small engines. So older snowmobiles, chainsaws, those kinds of engines, they don't have oil injectors, so you have to put oil in with the gas, mix it all up, and put it into the gas tank just like that. So how do you figure out that ratio of oil to gas? Because you do not want to mess that up. You'll have terrible results. And the last one on here, I can write ratios in different ways. So using a colon, those two dots, using the word to, T-O, using a fraction bar. Now I don't usually write my fractions like that. I like to write them up and down, keeping your fraction bar horizontal, and using the word per, or drawing a picture. So here's an example of a drawing to scale. So we're not going to draw a picture of a whole horse because we don't have a paper that's 8 feet long. We have a paper that is 8 inches long. So you have to draw your scale down to fit on your paper. So they're saying that the real horse is 1,500 millimeters high. The drawing is only 150. And so that's a scale of 1 to 10. So the actual horse is 10 times bigger than the drawing. And so you see that they've given a ratio right there in the corner. Oops, I'll do it down here. 1 to 10. And so you could apply that ratio and maybe draw another animal of the same scale, so they end up being the same size on the paper. Or you might want to know, well, the real horse's tail is 3.5 feet long, and so you can apply that scale to your drawing and know that you need to divide by 10 to get the drawing of the horse. Okay, other examples of ratio down here in the buckets. We're making cement. This whole chart is all about how to make cement. So you're going to buy a bag of cement. It's going to have a sort of a recipe on the back, and that recipe is going to tell you how much sand, how much water, how much stone, and so there's different ways to show that kind of a recipe. So the first one says, if you're doing a batch by the bucket, you would need 1 bucket of the cement, 3 buckets of sand, 3 buckets of stone, and that's going to give you an approximate total of 4.5 buckets. So you could say, well, I need, let's just say that this was a 4. We'll just cancel that last one out and say this is 4 buckets. So if I need 12 buckets of sand, or sorry, 12 buckets of cement to do my entire patio, I can use that ratio of, well, there's 1 to the total of 4. And so if I want 12, then I need to start with 3 bags of cement. So how I got that answer was what I did to the 4 to get the 12, I multiplied by 3. So I used that same special recipe over here. I multiplied by 3 and that gave me the 3. So if my original ratio was 1 to 4 and I want to triple that to get 12, then I would triple my original recipe of cement and use 3 buckets of cement. So there's all different kinds of recipes down here for cement. I just printed off the label of the cement bag of what it would tell you. So moving. So here we have a map of southern Manitoba mostly, and a map is a great way to show scale, and scale is just another way of writing a ratio. So what they've shown here on the legend down here in the corner is that for every 15 kilometers in real life on the highway, that is shown on the map in a section about this big. So it's saying 15 kilometers is about the distance of my red line there. So if you look on the map, let's look at Caryville, which is right here, and Gainsborough, which is right there. It must be about 15 kilometers apart because that is the same distance as what is represented on the scale. And so this would be a 15, I don't know what, that's maybe a centimeter. I blew up the scale, or blew up the whole map when I put it onto the slide, so it might not be exactly to scale anymore, but I bet you that was 1 centimeter back in the original map. So it's a 15 to 1 scale. And so if you look at the distance, maybe from Brandon all the way to Virden, you can see that there are, let's say about 1, 2, 3, 4, roughly 4 or 5. Let's say 5 for easy math. So we're going to say there's 5 of those chunks, 5 centimeters. And so how many actual kilometers would that be? So let's do the math on that. What did I do to the 1 to turn it into a 5? Remember, you're thinking multiplying and dividing only, not adding and subtracting. So I obviously multiplied by 5 because it got bigger. So that is what I need to do to this guy. So 15 times 5 is 75. So I'm not a map expert, but I would guess that Virden is about 75 kilometers from Brandon. So you can look that up on Google, see how close we are. Okay, here we have somebody's sausage recipe actually. So if you are a kid in Saskatchewan, you need to know about ratios because you will probably end up making sausage at some point in your life. And I actually had a student bring in a sample of their sausage after we talked about ratio, which was awesome. So good stuff to know. So this might be someone's recipe, and it is for 10 pounds of sausage, and you can see that they're going to use say 6 pounds of meat and 4 pounds of fat, and that equals the 10 pounds. And that gives them a fat content of 40% because 4 pounds of fat out of the 10 is 40%, right? Or it could be a 4 to 10 ratio, and this is, let me just change color here, part, and that is the whole. Okay. There aren't probably any sausage recipes that are just pure meat, one kind of meat, like you would probably have 6 pounds of deer and 4 pounds of fat or something like that. It's usually a ratio, and it doesn't have to be a 60-40 ratio, and they've given some examples of some leaner sausage. So in the last example, they're using 7.5 pounds of meat 2.5 pounds of fat, and that gives you a 25% fat content. So that's maybe a healthier option. And so those two numbers still add up to 10. You're still using 10 pounds, but your ratio is different. And so now you have 2.5 pounds out of 10, or 2.5 to 10 as a part to whole ratio. And so you can see how ratios are related to fractions, which are related to percents, and you can write them as part to whole, or you can write them like they did here as part to part. Happy sausage making. Okay, comparison problems are another very common use for ratios, and so what I have down here is how many kilometers will a plane fly in 4 hours if it's going 950 kilometers an hour? So what I like to do is make a little chart that will keep track of my kilometers on this side and my hours on this side. And so you're going to see words like each and per and every. You need to know what those mean. You're almost always multiplying or dividing. We don't usually compare with adding and subtracting. Same with ratios. It's usually multiplying and dividing. And so in this chart, I have plunked in the numbers that I know. So it said there was 4 hours. And so I put that over here on the hours side. It said that there were 950 kilometers, and so I put that in over here on the kilometer side. Okay, and then it says how many kilometers, well, we don't know, so I used an X, will the plane fly in 4 hours if it goes 950 kilometers per, doesn't say it, but it's per 1 hour right there. Per hour means per 1 hour. And so I've got my hours organized. They're talking about 4 hours, and then they're talking about 1 hour. And the 950 goes with the 1. So it's just a way to visually organize my information. And what goes with the 4? Well, let's find out. Sorry, there are lines drawn all over this chart. What did they do to the 1 to turn it into a 4? They obviously multiplied by 4, right? So multiplying by 4 is our magical equation that we're going to use, and that is what I need to do on this side. So I would take my 950 and multiply it by 4. So I'm going to do that in my head. It's going to be awesome. 900 times 4 is 3600, and 50 times 4 is 200, giving me a total of 3800. There you go. And it was asking how many kilometers, so 3,800 kilometers.